How are amines classified? They're classified as primary, secondary, or tertiary amines, and the classification depends on how many alkyl groups are, or the number of carbon atoms directly bonded to the nitrogen. So if we have something like this, we have one carbon atom directly attached to the nitrogen. Okay, that is considered a primary. Okay, this is a primary amine. Now, just to practice and review naming on amines, we look at that carbon chain. That's ethane. Okay. The E is replaced with the word amine. So, ethane, ethanamine. Okay. Common name would be ethylamine. Common name would be ethylamine. That's a primary. Now, if we have that amine and one of the hydrogens is replaced by a methyl. Now we're looking at a secondary amine. A secondary amine. Two carbon atoms directly attached to the nitrogen. If we wanted to name that, okay, it's still ethanamine, our longest carbon chain. Ethanamine. And we have a methyl attached directly to the nitrogen, so we do N-methyl ethanamine. Okay. N-methyl ethanamine. Now, if we have that same amine and we replace it, that hydrogen, with another methyl group, now we have a tertiary amine. Okay. And if we wanted to name it, we would call it N-dimethyl ethanamine. Okay. So, primary, secondary, tertiary amine. Look at the nitrogen. How many carbon atoms are directly connected to the nitrogen? Controls the classification. Primary, secondary, tertiary. Now, why that's important is we see variations or changes in properties of amines based on their classification from primary to tertiary. Okay? When you're in primary or secondary amine, we're really able to form some good hydrogen bonds. Okay? We're able to get some hydrogen bonding going. When we have that hydrogen bonding, that influences properties like solubility. Hydrogen bonding recognizes that we have strong polarity. Okay? And that influences solubility in water, lack of solubility in nonpolar solvents, so solubility. That also relates then to boiling points, melting points, freezing points, things of that nature. Well, when we have the presence or absence of hydrogen bondings. Now, let's see. When we relate these properties in amines to those in alcohols, because alcohols have the hydroxyl group instead of the nitrogen there. It has a OH there. We see similar properties in the fact that we have hydrogen bonding, but in alcohols, the oxygen being higher electronegativity than a nitrogen means that we get greater hydrogen bonding influence. So those intermolecular forces are typically greater in alcohols than in the amines. Now, one characteristic that we need to watch out for is when the amine carbons, so these longer carbon chains, when they get up to around 6 carbons and greater, we start to lose that hydrogen bonding influence, and the nonpolar dispersion forces start to have a greater influence or a greater dominance on those properties. Okay? One thing too specifically about tertiary amines is tertiary amines, we don't look for them to have that great hydrogen bonding influence. Okay, so not in tertiary amines, but present in primary and secondary. This is because in a tertiary amine, the issue is we have the 3 bonds that are directly to a carbon rather than to a hydrogen, where that hydrogen could then hydrogen bond with a neighboring molecule. Okay, so just some of the influences of that amine group on properties.